everyone. So yes, my name is Rohan Padhye. At CMU, my research group is called the PASTA Lab, which stands for Program Analysis, Software Testing, and Applications. So as you can see, I'm not a lawyer. I spend most of my time thinking about spaghetti code. But today, I am actually going to talk about legal reasoning. And I presume that most of you in this room are not lawyers either. So let me just start off with some context. So there's a Wall Street Journal article from just about over a month ago, this is August 24, discussing a very interesting case where the US Congress, turns out I guess it's sort of messed up. It put a wrong date in one of the tax legislation. So in 2017, Congress overhauled the US tax system quite a bit, made lots of changes. In one particular case, they made changes to the tax law concerning US companies that have foreign subsidiaries. And so they wanted to incentivize companies to send money from the foreign subsidiaries back to their US parent companies. And so they allowed these sort of foreign dividends to be considered a tax deduction. But it turns out this was in conflict with another part of the tax code, which actually allowed foreign tax credits to be also considered as dividends. And so this opened up an opportunity for companies to double dip and count the same sort of dollar as both a foreign tax credit as well as a deduction. Now, Congress sort of figured this out, and they wanted to sort of allow one way of using these dividends, but not the other. But unfortunately, the dates that they used to enable one interpretation and disable the other were actually inconsistent. And so there was like a 1-year overlap period where companies were actually able to use hundreds of millions of dollars to double dip and use them both as deductions and credits. And so this was, I guess, a net loss for US taxpayers like me. So, what could they do about this, right? Like, could they have sort of figured this out early on? So we are in 2024. So basically, everybody has now, moved on to thinking about AI, right? And so they're like, well, could you have asked LLMs to go and find such loopholes in the first place and help lawmakers identify these kinds of inconsistencies or conflicts in the law? And so, you could potentially try to just, give all of the legal statutes to an LLM and say, go find me loopholes. It doesn't actually work. There's like millions of words in the US tax code, for example. But today I'm going to argue that this is basically a program analysis problem. And to zoom out, this is not only to do with tax code. This kind of legal reasoning turns out to be important in many sort of application domains. So tax law is usually the canonical example. But think about reasoning about documents like wills or trusts, right? So you're sort of writing down under what conditions how money should move when a person sort of passes away. Think about the law that deals with social security benefits and retirements, pensions across many different countries. In the US, there's law for things like student aid and determining based on a person's sort of income as well as their assets, how much federal student aid they can get for college tuition. Think about credit card agreements that you sign with your banks that determine how much interest or penalties you might have to pay depending on when you sort of pay your credit card bills. A rental agreement that you might sign with your landlord that again talks about things like penalties. Or most of you probably took a flight to come to this conference and you had to sign some terms that sort of outline what the cancellation fees would be or when the airline should give you a penalty if the flights were delayed. So all of these are sort of legal texts that eventually compute some sort of numeric value out. And for any sort of situation that might arise, the final answer is supposed to be like a deterministic calculation based on applying a bunch of rules. And that's what that process is called deductive legal reasoning. So that's in contrast to this analogical form of reasoning that's often done in courts where like judges look at what judges have done in the past in previous cases and apply to that. So in these documents, we're thinking about the purely deductive form of reasoning. And it turns out that this deductive reasoning is actually very mechanical once all of the facts are known. So of course, in law, there's always going to be lots of sort of ambiguous terms. So things like in tax law, you might have, you might be able to deduct reasonable expenses, whatever that means. Or, there might be some sort of determination of if you're sort of trading baseball cards and making money out of it. Is it a hobby or is it a business? And so there's lots and lots of ambiguous terms. But assuming that you can actually define what those terms are and all of that is settled out of court, once all of the facts are truly known, the act of the process of coming up with the final numeric computation is highly mechanical and is almost like executing a program. So let me give you an example with the US tax code again. So here's a case study. You can read it out. It's very similar, actually, to the case study used in the ChatGPT-4 demo. So that's why I used it. It says, Alice and Bob are married and filing taxes jointly for the year 2018. They're taking the standard deduction. Alice was born in Jan 1981. Bob was born in 1975. In 2018, Alice and Bob's adjusted gross income was some amount, 200,000 something. They both do not itemize the deductions, and they only qualify for the standard deduction. What is their taxable income for the year 2018? Fairly straightforward answer, very straightforward question. But to answer this, you need to look at the official tax statutes. There's lots of statutes, and I'm going to show you some of them. I know the font's really small, and you don't have to read all of it, but I'm going to highlight some parts. This is from Section 63 of the US Tax Code that talks about how to define taxable income. And it says that taxable income is defined as adjusted gross income minus a bunch of other things, one of which is the standard deduction. Standard deduction is defined essentially as the sum of the basic standard deduction and the additional standard deduction. The basic standard deduction, because this is a joint return, is actually 200% of whatever value is in paragraph 2C, which turns out to be $3,000. So that's $6,000, right? No, wrong. Because in another section, there's adjustments for inflation. And so in adjustments for inflation, it says that whatever value you saw in paragraph 2C, actually, you need to adjust it for cost of living based on section 1F3. So there's like a function call to section 1F3. And then it says, by the way, in section 1F3, you might see this term called calendar year 2016. Actually, replace that with calendar year 1987. So it's a parameterized function call. And then, of course, there are some limitations for some people who are not eligible to even have the standard deduction. And then it says, wait a minute. If you are in years 2018 to 2025, which we are because this is 2018, then actually treat paragraph 2C not as $3,000, but as $12,000, and then do all of this calculation again, right? So this is fairly simple, right? So this is highly mechanical, and you can actually treat this as essentially software execution. And that's sort of the key insight in all of this. Now, of course, I'm not the first person to think about this. There's a lot of work on trying to actually formalize the law and come up with formal logics or domain-specific languages and just execute those models and prove properties about legal documents. But to be honest, those kinds of approaches haven't taken off to a large extent. One sort of aspect is that lawyers don't really think in terms of formal logic. They're more used to negotiating these sorts of laws using natural language. So the contemporary approach, right, that people are thinking about is, what if we just ask LLMs to interpret these laws directly? Can we come up with some results? There's also another alternative path, which is asking the LLMs to actually synthesize the formal models and to execute them. That actually turns out to be really hard. I have some students from our department talk about their experience doing this at the ProLala workshop on Tuesday. But for the purpose of this talk, I'm going to only consider the case where you're using an LLM and directly interpreting the natural language law. And so what I have observed is that these LLMs essentially can be thought of as interpreters of natural language programs, where the inputs, like the gray box on the top here, is again a natural language, right? So you have natural language inputs, natural language programs. The outputs are usually numeric or sometimes Boolean. Of course, all of this is noisy because LLMs are unreliable, but that's sort of the paradigm that people are thinking about using. And so when you're thinking about this kind of software execution, the meta-analysis problem, which is thinking about all of the hypothetical cases that might arise in this document, thinking about loopholes, inconsistencies, and incompleteness, essentially is just a software analysis problem, right? It's very similar to saying, can we find software bugs or vulnerabilities, or can we validate certain properties that our software should satisfy? And so my main argument in this talk and in the paper that I wrote was that this process of AI-driven legal reasoning can actually benefit from 50 plus years of software engineering research that we have done, and we can use some of these principled software engineering techniques to make some of these sort of reasoning processes a little bit more tractable. So I'm going to give you several examples of how we can use these techniques. So the simplest one that we could use is test coverage. We all know about how to use test coverage. So what I actually did is I gave this prompt that I've showed you earlier to an LLM. I gave it to Anthropic's Claude 3 Opus LLM and said, can you actually solve this using chain of thought reasoning? And by the way, while doing this, please list down all of the sections, paragraphs, and rules that you actually had to use while coming up with the answer, and also which of these sections actually applied. And Claude happily does that for us. And so we actually get an execution trace, which tells us the subset of the legal statutes that are required for reasoning about this particular example. And it actually gives us the right answer, which is that their taxable income is $192,350. So we actually have a nice coverage trace for one particular input. Now that we can do this, we can, let's say if you wanted to come up with new test cases, you can use the idea of doing coverage-guided test synthesis. So you can say, hey, by the way, I have this a section in the statutes, 63F1, that has 2 subsections, A and B. I actually would like some examples. I want an example that in which paragraph B should apply, but A should not. So paragraph A deals with what happens when the taxpayer is 65 or above, and paragraph B deals with what happens when the taxpayer's spouse is 65 or above. And so the thing in the gray box is the prompt that I gave to Claude, and it happily synthesized a test input for me. It says that Claude and Charlie and Diane are married and filing taxes jointly. Charlie was born in 1985. Diane was born in 1953. And so Claude gives me a reasoning saying that Diane has attained age 65, but Charlie has not. And therefore, 63F1A does not apply, but 63F1B applies, which actually turns out to be the correct form of reasoning. So you can actually do coverage-guided test generation and generate test cases for the section that you care about, which is useful for documentation as well as just making sure that your laws actually make sense. The other thing you can do is if you actually really want to know what a particular clause in your statutes do, is you can use mutation testing to reason about what happens when that particular clause changes. So here's another prompt that I gave to Claude. I said that I'm going to modify so in the same section again, there's this clause here in paragraph B, which says and an additional exemption, blah, blah, blah. I don't know what that means, so I'm going to strike it out. And now can you give me an example such that the, I guess, with the modified rule would apply, but with the original rule, that example would not make sense. And so Claude actually can figure this out. And so it gives me another example saying Ellie and Frank are married, but they're filing taxes separately this time. They give me some date of birth for Frank, who has an adjusted gross income of $50,000. And it gives me a bunch of reasoning. And it says under the modified rules, 63F1B would apply because Frank has attained age 65. But in the original rule, it would not apply because Frank has gross income, and therefore, Frank cannot claim some additional exemption. So it does some reasoning, and this turns out to be correct. So you can the main point here is that you can get an example such that the interpretation is different under the original rule as well as the modified rule. And finally, we can do this form of meta-analysis, right, which is thinking about properties that we might want our legal documents to satisfy or not. So for example, let's assume the person who was drafting this legislation about standard deductions and inflation adjustments was thinking, well, what happens as we have, let's say, different economic data coming in, can the standard deduction decrease year over year because of the inflation adjustments? So I first tried to give Claude this question directly, giving the legal statutes and the section for adjustments to inflation. And Claude actually gives me the wrong answer. So it says, nope. If you look at the statutes, the adjustments for inflation say that the deduction shall be increased, and shall be increased means that it cannot be decreased, and so there's no way that your deduction values can actually decrease year over year. This turns out to be the wrong answer. So that's because this problem is not super tractable for Claude, at least as of yet, because you're asking sort of too many things. And so we can break this problem down using the concepts of property-based testing. So what we can do to answer this question is we can say, let's pick some random values for a tax year, as well as some hypothetical values for the consumer price index, which is the economic data that the US government uses to decide what inflation is. And then once we have this input, we actually know that Claude can just compute the standard deduction for a given year and a given value of CPI. So that's a simpler problem for the LLM to solve. And so now I can randomly sample many values of years and CPI values and check that is there a case where Y1 is less than Y2, but the standard deduction in Y1 is actually more than the standard deduction in Y2 for the same CPI values. And I can do this many times in a loop. And it turns out in just a few iterations, I think it takes like a couple of minutes for Claude to actually give a interpretation where the standard deduction actually can decrease year over year. And it turns out that there's like a nuance to when this happens. It happens if a future year CPI value is less than the current year CPI value, but both of these years have a higher CPI value than the base year of 2017. That's when this can happen. It's a sort of a corner case. But you can figure this out by essentially running this entire property-based testing algorithm in a loop, in a script, sort of outside, and only using the LLM for like step 3, which is computing the standard deduction for a given year. So you're trying to sort of reduce the the unreliable base of the LLM LLM-based interpretation in your overall reasoning process. There are lots of other possibilities also that you could sort of imagine. You could do like delta debugging and say, can you give me the smallest test case such that a particular section or rule applies? You can potentially do something like change impact analysis, right, to validate amendments, right? If you want to prevent issues like the one that the Wall Street Journal article pointed out. So you're making a change to a tax law or some other document, and you want to reason about what happens when I apply this change. How will it affect existing test cases, and which of my test cases will have a different interpretation with the new law compared to the old law? And finally, I haven't really tried this, but maybe there's a way to even prototype new amendments using ideas from automatic program repair. Because if you have a bunch of test cases, maybe we can come up with new test cases that we want to be satisfied in a particular way and say, can you give me a change to the law such that this particular test case can be interpreted in a certain way? So that's something I haven't tried, but it's a fun sort of thought experiment, at least so far. So to summarize, people are already using, or thinking about using AI-based systems for legal reasoning. This sort of turns out to be a way of treating natural language documents as programs and interpreting them in a sort of noisy fashion. So my argument is that this paradigm can benefit from the application of principal software engineering techniques that we already know. And I hope that this sort of idea opens up maybe a field of research at the intersection of software engineering, AI, and law. Thanks so much, and happy to take any questions.
Questions? While you're queuing up there, a quick question on my side. I was very surprised at an early slide where you said that you want to get the AI to do the computation for you. And my understanding was, at least with models like ChatGPT, that they're very good at transformation, but they're terrible at actual computation. So I would have expected transforming to a model that you can execute would make more sense. So is Claude different then, or?
I think all of the models have gotten better at simple arithmetic now. I think the older models used to struggle with this. This has become better, at least in my experience. The main thing that I've seen, the main failure mode I've seen for these models is not so much the arithmetic, but is in making sort of multiple passes over the natural language document. If you're making a simple computation, in most cases, if it's a linear pass, like you're sort of going over each section once and you have a chain of thought reasoning, it does fairly well. But when you have these sort of embedded function calls and recursion in the statutes themselves, that's when things start getting crazy. And so what I've observed is like if you can break that process down and only have the LLMs reason about the sort of the linear process, that ends up being much more accurate.
Super cool. Thank you.
Yeah, let's stay on this slide. I had two questions. One was about this slide. One was, so you said you had Claude do the standard deduction. That's like a function, or did you have it like write code for the standard deduction as a function, or did you have it compute a table by year?
No, so this step compute standard deduction essentially was just a prompt, right? So it was a prompt with some variables for year and CPI values. I just gave it the CPI values and I think like a comma separated list and the year, and I said that can you apply this particular section and tell me what the standard deduction would be in 2025 and 2026 based on hypothetical CPI values.
And so then how many values did you pass to that, and like how did you validate?
So at one time, if I were giving Claude, I would give only one value for the year, one value for the CPI, one table for CPI, and I would store the result. And I would do this for many different values of year, many different values of CPI. So the CPI values and the years were randomly sampled.
And then when you did it, once you'd done it for a year or a whole bunch of years, how did you validate that those results?
So this part is this assertion, check if y1 less than y2 and standard deduction greater. This was all in Python. So there was
no, that just tells you whether there's a decrease. But
yes.
You said that compute standard deduction,
yes.
You just hand that to Claude and Claude gave you a result.
Right.
How did you know that result was?
How do you know the result is valid? I don't. Yeah. So the thing is, at the end, you still have to validate if the so whatever the standard deduction is, Claude is going to give you a number. I'm just taking it at face value, and I'm doing this check. That actually could be a bad value.
At the end, you only have to manually compute 2 years.
I only have to manually check if the counterexample that it gives me is valid or not.
I see.
I don't have to validate every single step.
So those have to manually check, but you only had to do it for 2 years. That's
By the way, all of this, all of the examples that I showed you, including this this loop, this is on GitHub. All the transcripts are on GitHub, and there's a link from the paper.
Okay, and the other question shorter. So for 1 through 3, you were saying, oh, Claude did that correctly. Was it, these were all like, they were 0 shot? Did you have to play with the prompt a lot?
Oh,
like
for
how
the
much
previous
did you-
ones? Yes, same question. So here, I had to, so there again, all the transcripts are on GitHub, but I believe I used chain of thought reasoning. And the only thing I gave it in the system prompt was about all of the statutes that were used. So it was, I sort of manually did the retrievals. I didn't give it the entire US tax code because that's 2.4 million words. So I gave it all of the statutes that are relevant for computing taxable income and standard deductions. Turns out to be, I don't know, maybe several hundred or maybe a couple thousand words. And then asked it to do chain of thought reasoning.
And then the first try, and it would give you the right result.
Yeah, for things like this, it's like, yeah, very easy. There's just first try. Yeah.
Yeah, thanks. Always interesting to know what these LLMs can do. So I guess it's actually kind of a similar question to what came up in our talk. So like Claude says, yes, very confidently, right? And then you check up on it again, and you're like, no, actually not.
Yep.
But how do you know that yes is bogus?
How do you know so in all of this, you actually you never know whether yes or no is right or wrong, right? So I don't see these kinds of tools being used in automated like decision making or thing, right? So if you think about what do lawmakers do today when they're drafting legislation, or what does a lawyer do when they're drafting a contract, right? They're using Word, mostly using Control F and saying, if I change this particular section, is there another, how many other sections have this particular phrase called inflation, and let me see what happens, right? And so, these kinds of tools are essentially an enhanced form of Control F, which just allow you to like get, maybe potential counterexamples that you can then go and validate manually. But by no means is this tool actually making the decisions for you. So, you really can't rely on the output of what this gives you.
Yeah, fuzzy Control F.
Yes, fuzzy Control F, exactly.
This is very cool and very thought-provoking.
Thank you.
So the current sort of hot topic in the like LLM training world is like chain of thought, training with chains of thought, and it feels like this would be very amenable to this. I was wondering how much manual work did you have to do to construct these prompts and get the model to sort of reason through the problem, and then could you think of a way to mechanize that and generate that at scale?
It's a good question. I haven't thought about that much. Again, I should preface by saying I am not a LLM expert by any means. I don't even I don't use these tools as well as some others in day-to-day research. So how much manual work did I have to do? Not much actually. So I guess the manual step that I did do was select the sections from the tax code that were relevant for these particular cases. But that was not something that I did. Like I borrowed the subset of the statutes from a data set called the SARA data set, which is already used in by others who were doing AI-based legal reasoning. So for me, it was not a lot manual work, but from a framework point of view, there was a manual step of selecting these statutes as a subset of the entire US tax code. So that was like magically selected, right? Because the lawyers knew which sections apply. I don't know how to go from. So for example, if I go back to the Wall Street Journal article, that's many slides ago. But anyway, so the one where there was a there we go. Inconsistency because of the wrong dates in the foreign tax reduction. I tried to see if we could use the same technique to find this loophole. It's actually very hard because the changes are way more complex. They hit a lot of other sections. And so what you want is when there's a particular section of the statutes, all other sections that particular section references, you would need in your sort of context window. And so you sort of have to do a transitive traversal of the section dependency graph. Yeah, and then that becomes really hard. And so I don't have a way to automatically get the the subset of sections that are relevant to find something like this yet. So that would be something interesting to explore.
Thank you.
Yeah, RAG, but like I don't, like it's not obvious because this is like. There's so much going on in the tax code. The examples, I heard a few people laughing in the audience when I gave the examples of the adjustments for inflation. Trust me, this is not even like the 10th most complex piece of the statute that I've seen in this, in the tax code. So talk to me offline afterwards for more complex, crazy examples.
Thanks for the talk. So you are mentioning, I think, that sometimes you have statutes that are ambiguous. And what I'm wondering is, how does an LLM like Claude handle these things? Does it resolve the ambiguity in one way or the other? how does this interact with, for instance, a statute that was left ambiguous on purpose so that it would be subject to legal interpretation by a judge later down the road?
Yeah, that's a good question. I actually don't know the answer to that because in all of these statutes that I gave it, since I picked the statutes from the SARA data set, the previous researchers who had compiled this data set picked statutes where I think for all of the questions that I posed, there was actually a deterministic solution. And so I have actually not tried giving Claude ambiguous statutes and seeing what it does. So I actually don't know, but I'll try it out.
But so I guess, as a follow-up question,
Sure.
If you were to give it some ambiguous statutes and Claude would decide one way or the other, resolve the ambiguity, do you see it as intervening or rather replacing what a judge would usually decide?
No. I mean, as I said, you can't believe anything that comes out of this, right? So this is just a tool would ever allow people who are working with either contracts or legislation, insurance policies, whatever they're drafting, to get examples or counterexamples that they can then use to apply their own lawyer brains and manually reason about these things. But this is just a way to sort of maybe like suggest. These are like suggestions, like, hey, have you thought about this case? And the lawyer can say, you know what, this is fine. Like, you're wrong. I've dealt with this case. Don't worry about it. But I don't think you can trust the interpretation in any legal sense, whatever, right? Okay. Yeah.
Done with questions? No last question? Yes?
I have a question.
Oh, great.
So I was actually teching for the ProLala workshop that happened, and they had an interview. They had a conversation with Matthew Butterick.
Yep.
And someone asked him a question about like, oh, do you think like we can use programming to help find loopholes and things like that? And I really liked his response, which was that these loopholes are intentional. Like, lawyers know what they're doing when they do these things, right? Like, do you foresee this as being a tool that like actually gets used, or that like that Congress intentionally put the wrong date, or like intentionally makes mistakes like this that can get waved away as, oh, a really complicated loophole?
Yep, thanks. It's an excellent question. I think I was the one who asked Matthew this question, and so it was an interesting response. I don't entirely agree with that viewpoint, and I've spoken to some tax lawyers about this as well. And so for example, in this particular case, you see the subtitle says Republicans and Democrats tried separately to fix a hole. So there was a bill in the legislature called the Technical Corrections to the Tax Cuts and Jobs Act of 2017, which was basically a set of, we need to fix these bugs in the tax code because they were unintentional errors. They were not intentional. So these are actually unintentional errors that the people who drafted the original legislation figured it out and immediately came up with this suggestions to fix it. Unfortunately, so it's almost like a pull request. But unfortunately, the pull request was not merged because the second time around, the technical corrections didn't actually pass because somebody else decided, they had to have a political fight. And so I guess partly some of these things are intentional, some of them are not. It's all like the final law that gets voted on is a result of negotiation. And so the negotiation happens because the legislators are reasoning about all these edge cases and corner cases, and so at that point they're still using some tools like this to reason about what happens. And so, so at least in this case, I know there was at least one example where there was someone dissatisfied with the outcome, and they would have liked to have fixed it, but they couldn't. And so essentially, you had a pull request with all the vulnerabilities out there for people to exploit. And so there are definitely use cases where this can happen. And the other thing is, this is only in the case of legislation. I gave a lot of other examples where you might be drafting a will, in which case this is you and your own assets, and so you care about this. So you're not intentionally putting ambiguities in your own will. So or if you have an insurance policy that you're a signatory to, or you're something else. So in those cases, if there's two business entities that are negotiating over a contract, each one of them cares about edge cases that might affect them negatively, and so they always care about this, these kind of reasoning processes. But yes, you're right that many of the loopholes that exist in the current law are intentional, and in those cases, good for the people who put them there. Thanks.
I think we've come to the end of the round of questions, so I'd like to thank all of our speakers from this session once more.
Thank you.